Have you ever been stuck in that frustrating maze of healthcare referrals? You know the one I mean. You finally get a diagnosis, great, but then you're handed maybe a piece of paper or told someone will call, and suddenly you're just wading through endless paperwork, making call after call and waiting, just endlessly waiting for that next crucial appointment. It really feels like you're sending your care off into some kind of black hole when all you want is to get to the next step.
Oh, absolutely. It's honestly a huge problem across North America. Patient referral management is just, well, it's bogged down with inefficiencies.
Hmm.
We're often talking about systems still leaning heavily on really outdated tools, like fax machines, printed records.
Fax machines, really.
Yes. And the stakes here are incredibly high. Think delayed diagnoses, missed appointments, compromised care continuity. These are common issues, and they're not minor inconveniences for patients.
Not at all.
And then for the providers, from a financial standpoint, there's significant revenue loss. It comes from what's called referral leakage. Yeah, that's when patients end up seeking care outside a specific network.
Yeah.
Maybe because the process was too slow or confusing. It's honestly astonishing, but some figures suggest nearly 75% of North American healthcare providers still use fax for referrals.
75%. That's,
Yeah.
wow. It's almost unbelievable, isn't it? Like something out of a time capsule. My kids probably wouldn't even know what a fax machine is, and yet it's still kind of core to parts of our healthcare system. That number, it isn't just an old statistic. It really speaks to this deep, almost systemic inertia, in a sector where precision should be everything. It really highlights how something like generative AI isn't just an upgrade. It feels more like a true disruption to these deeply ingrained habits.
Exactly.
So for this deep dive, our mission really is to unpack exactly how this powerful new technology, generative AI, is stepping in, how it's working to untangle this incredibly complex system, offering maybe a shortcut to more efficient, higher quality patient care. It sounds like it's proving to be far more than just a productivity tool. It's maybe more of a strategic asset.
Precisely. And the core challenges in referrals persist because, despite digital advances everywhere else, healthcare is still burdened by these legacy systems, these manual tasks. That 75% reliance on fax we mentioned, it directly leads to delays, errors, lost information.
Right, just basic operational friction.
Exactly. And you also have these prior authorization processes. They can take days, sometimes even weeks, because they're so manual. That creates a huge bottleneck for getting crucial treatments approved.
Weeks just waiting for approval.
It happens. And then there's that significant issue of referral leakage we talked about. Roughly 15% of referrals might result in patients leaving the network. That hits a provider's revenue, sure, but critically, it fractures the continuity of care. It often means the left hand doesn't really know what the right hand is doing with a patient's treatment plan.
That's the real kicker, isn't it? It's not just some abstract problem for hospitals or clinics. Think about how these inefficiencies directly impact your experience as a patient. That fax not going through maybe, or that manual authorization getting stuck somewhere in a pile. It could lead to preventable readmissions or just a really fragmented care journey where your doctors aren't communicating effectively.
Absolutely.
And for the health systems themselves, especially now with the big shift towards value-based care models, where they get paid more for better patient outcomes, not just for doing more procedures, this kind of efficiency isn't just a nice to have anymore. It's a critical performance metric. It directly impacts the quality of care they can deliver and ultimately how they get compensated. It changes the whole game.
It really does. Now, when we talk about generative AI in this healthcare context, it's important to define it clearly because it's so much more than just, a fancy chatbot answering basic questions.
Yeah.
It's a category of AI models specifically designed to generate new content. That could be text, summaries, maybe even draft decisions, all based on existing data. These systems are built on what we call large language models, LLMs. You might hear names like GPT-4o, Claude, Gemini. They've been trained on just vast amounts of medical literature, clinical protocols, administrative records. It's like they've read the entire medical library and then some.
That's a helpful way to put it. But I'm curious, how does it feel different in practice compared to the AI we might be more used to? The kind that might just flag an anomaly on a scan or automate a really simple task. What makes this a game changer for something as messy as medical referrals?
Yeah, that's a great question. What truly sets generative AI apart is its ability to understand context. It can synthesize really complex information from these vast, often messy, unstructured data sets. And then it produces output that genuinely mimics human reasoning and, importantly, human language. This capability makes it uniquely suited for the kind of data you find everywhere in healthcare, unstructured notes, Jargon-heavy reports, fragmented records. Think about it. It could potentially pull meaningful insights from a scanned discharge summary, pages long, or interpret maybe some nuanced handwritten physician notes, which are notoriously hard to digitize accurately, or even compose a concise patient summary, complete with accurate diagnostic codes like ICD-10 codes from a really convoluted patient history.
That's fascinating. So it can interpret and generate like that. How does this translate specifically to managing referrals then? What's the practical application day to day?
Well, in referral management, generative AI offers a pretty transformative shift. Instead of just matching keywords, it can interpret the full clinical intent behind a referral. It can truly understand the patient's underlying needs based on their whole record, not just the referral note itself.
Ah, so deeper understanding.
Exactly. And it excels at intelligent summarization. It could condense, say, a 10-page patient history into a brief, digestible referral summary for the specialist, highlighting only the most crucial details. That saves the specialist immense time. And it can apply predictive logic. It can suggest the most optimal specialist or perhaps post-acute care facilities, factoring in not just the diagnosis, but also geography, insurance plans, even maybe patient preferences if that data is available.
So it's not really about replacing the human element, the care coordinator or the clinician, right? It's more like enhancing their capabilities, giving them better tools, sophisticated pattern recognition, actionable insights right when they need them.
That's precisely the idea.
But I guess some listeners might still be wondering, where exactly does the human decision-making end and the AI's influence begin, especially in complex cases? Are there guardrails?
That's a critical point, and yeah, we'll definitely dive into that more when we talk about compliance and safety. But for now, think of it as a superpowered assistant. The AI provides the intelligent summary, maybe the best fit suggestions based on data. But the final clinical decision, the sign-off, that always remains with the human professional. It's about making them faster, more efficient, and better informed, not automating away their crucial expertise.
Okay, that makes a lot of sense. So we've painted a pretty clear picture of the challenges and the unique power of generative AI to tackle them. But the real question is, how is this actually playing out on the ground right now? Can you give us some concrete examples? Are hospitals actually seeing these changes today?
Absolutely. Let's walk through some concrete, real-world transformations that are happening as we speak.
Great.
Okay, first up, automated intake and document parsing. Generative AI can automatically classify and just parse mountains of referral documents, faxes, PDFs, scanned images. It quickly extracts the key information needed. We're seeing healthcare providers reporting up to, get this, a 70% reduction in manual processing time.
70%.
Yeah, using AI-driven optical character recognition, OCR, and data extraction. That comes from a 2024 Chilmark report. That's a monumental shift away from staff manually sifting through piles of paper or trying to read blurry faxes.
Huge time saver.
Immense. Next is prior authorization acceleration. This is a big one. AI can help generate clinically appropriate authorization requests that align with specific payer guidelines. This significantly speeds up a process that used to be a major bottleneck. There's a U.S. hospital network, for instance, mentioned by the CMS Innovation Center in 2025, that reduced their authorization turnaround time from an average of 5 days down to less than 24 hours.
5 days to less than 1.
Using AI referral automation for a patient. Think about that difference. It's going from agonizing uncertainty to potentially getting rapid access to the treatment they need. It really shifts the experience from just waiting to actively getting cared for.
That's a tangible impact on patient well-being right there.
Definitely. Then there's predictive matching and referral management. The AI analyzes patient data to match them with the most optimal providers for their specific needs. Studies from KLAS in 2025 suggest referral leakage reductions of up to 60% when using these AI-enhanced workflows.
60% reduction in leakage? That's
Yeah.
massive for continuity and the bottom line.
It is. It's about getting the right patient to the right specialist at the right time, preventing them from falling through the cracks in the system. And then there's enhanced patient communication and follow-up. AI can help generate personalized communications automatically. Appointment reminders, prep instructions, follow-up checks. This significantly improves patient engagement and helps reduce no-shows and cancellations, which was a huge headache and cost for health systems.
It keeps patients in the loop automatically.
Exactly. And finally, advanced analytics and reporting. The AI can provide really deep insights into referral patterns. It can identify bottlenecks in the process, maybe predict outcomes based on certain factors, and help health systems continuously refine their workflows. It feeds back into getting better.
These really are game-changing improvements. It's not just theoretical. You can see how these efficiency gains directly translate to better, faster care for you, the patient. Getting that specialist appointment sooner, having your authorization approved quickly, that's tangible progress. It's not just about saving the hospital money, it's about saving your time when it truly matters.
Indeed. Now, for any health systems listening and considering adopting this, it's important to understand that implementing generative AI is a strategic, thoughtful process. It's not just flipping a switch.
Right, healthcare systems are complex beasts.
They really are. So it typically involves a phased approach. Phase one is all about assessment and readiness. This means really documenting your current end-to-end referral workflows, what actually happens today. Auditing your existing data, everything from HL7 messages, those standard clinical data exchanges, to scanned forms, clinician notes, making sure it's suitable and ready for AI processing. It also involves getting all the stakeholders aligned, clinical coordinators, IT folks, leadership. Everyone needs to be on board. And of course, selecting an AI provider that has healthcare-specific LLM capabilities and a really strong compliance posture, that's critical.
Laying the groundwork.
Precisely. Phase two is pilot deployment. You start small, maybe a limited rollout in just one service line, like cardiology perhaps. Test the performance in a controlled environment first. This involves integrating the AI model with your existing electronic health records, your EHR. Often using modern, secure standards like SMART on FHIR, which helps different systems talk to each other securely and seamlessly. Then you train the staff who will use it, and you closely monitor key performance indicators, or KPIs. Things like referral turnaround time, completion rates, user satisfaction.
Test, measure, learn.
Exactly. Phase three is then scaling across departments. Once the pilot proves successful, you standardize those refined workflows. You fine-tune the AI models based on the feedback you got, and you ensure there's smooth coordination across different systems, especially if you have multiple facilities sharing patients or data.
Getting it rolled out more broadly.
Right. And phase four is continuous optimization.
Yeah.
This isn't a one-and-done thing. You need ongoing feedback loops with the users. You need to maintain version control on your AI models and the prompts you use, conduct regular compliance reviews, and maybe explore expansion into adjacent areas where it could help, like discharge planning, perhaps.
So it really is about building a future-ready system. It's a strategic investment, thinking about the long game of healthcare delivery. But of course, the big question always comes down to money. What does this cost, and what's the return? How do health systems even measure the ROI, the return on investment on something like this? It seems complex.
It is multifaceted, but definitely measurable. ROI is looked at through both quantitative and qualitative metrics. Quantitatively, it's about the tangible gains, time saved on administrative tasks, that's staff hours freed up, revenue generated from reduced referral leakage, fewer payer denials, which means less lost reimbursements.
Hard numbers.
Exactly. But then there are the qualitative benefits, which are just as important. Enhanced clinician satisfaction, less burnout from tedious manual work, and of course, a significantly improved patient experience, which is increasingly tied to reimbursement anyway. It's truly a continuous improvement process. The benefits tend to compound over time as the system learns and workflows adapt.
And what about the actual costs? We often hear about AI pricing in terms of tokens. What does that actually mean in this context, and how do these costs add up for, say, a hospital processing thousands of referrals?
Yeah, the token pricing model is pretty standard for these text-based AI models. You can think of a token as roughly a piece of a word, maybe 3/4 of a word on average, or just a few characters. So it's essentially like a per word or per character cost for the AI to process input text or generate output text. Usually it's priced per million tokens. For a typical referral packet, let's say it involves processing maybe 2,000 tokens of input, like the patient's history and notes, and generating 500 tokens of output, like summary for the specialist. Based on illustrative pricing from around June 2025, a single packet like that could cost, well, it varies, maybe less than a cent using a model like Google's Gemini 1.5 Pro, maybe just over a cent with Anthropic's Claude Sonnet, or perhaps around 1.5 cents, so 0.014 I2, with OpenAI's GPT-4o.
Pennies per referral, but that adds up quickly at scale, right?
Absolutely. If you're processing tens of thousands of these monthly, those pennies turn into significant sums. And there are nuances that really impact these costs too. For example, batch versus real-time processing. If you can process a high volume of referrals overnight in a batch, rather than needing an instant response for each one during the day, that can sometimes have your per token bill.
So timing matters.
It can. Then there's cloud lock versus portability. If your patient data is already stored with a major cloud provider like Microsoft Azure or AWS, using their native AI services can be beneficial. The AI is co-located with your data, which can help avoid extra data egress costs. Those are fees for data leaving their network, and it might simplify managing user identities and access.
Keep it all in one ecosystem.
Potentially, yeah. And regulatory headroom is another factor, especially for health networks operating across regions or borders. For instance, Azure currently tends to offer the broadest list of regions globally where data can be processed, which can be helpful for things like US-Canada cross-border operations. Other providers might require workloads to be pinned to specific healthcare certified regions, which might be more limiting depending on your footprint.
Good point for larger systems. Any practical advice on managing these costs?
Yeah, one common strategy is blending models. You don't necessarily need the most powerful, most expensive model for every single task. You could use a cheaper, very capable model like Gemini 1.5 Pro for the high volume, more straightforward tasks like initial document intake and parsing, and then escalate the more complex edge cases, maybe referrals with really ambiguous notes or multiple comorbidities, to a premium model like GPT-4o for higher accuracy, where it counts most. This kind of tiered approach can potentially cut your overall token spend by maybe 30–40% without really sacrificing accuracy on the critical cases.
Smart optimization. Now, as fascinating as the tech and the ROI are, we absolutely have to talk about the unavoidable truth here: compliance and regulatory safeguards. We're dealing with incredibly sensitive patient health information. How are these systems possibly protected? What are the rules?
Absolutely crucial topic. Healthcare organizations implementing any AI, especially generative AI handling patient data, must prioritize compliance right from day one. It's non-negotiable. In the U.S., the main framework is IPAY, the Health Insurance Portability and Accountability Act. In Canada, you have provincial laws like FIMAVA. In Ontario, the Personal Health Information Protection Act. These acts mandate really rigorous standards for patient data privacy, security, and auditability, and they apply directly to AI systems involved in patient care workflows.
So what does that mean in practice for the AI?
It means several things. First, data encryption. All protected health information, or PHI, must be encrypted, both when it's stored at rest and when it's being transmitted in transit. It means robust access controls. Only authorized personnel should be able to access sensitive data, and usually based on their specific role. Strong identity management is key. There must be comprehensive audit trails. Every single prompt given to the AI and every output it generates that involves PHI must be logged. This is for compliance reviews, security monitoring, and accountability. And if AI models are being trained or fine-tuned on patient data, de-identification of those inputs is absolutely essential to prevent privacy violations.
Ah.
All personal identifiers must be removed or masked.
Okay, encryption, access, audit trails, de-identification. What else?
Well, since many AI platforms run on public cloud infrastructure, data residency is key. Generally, patient data must be stored and processed on servers located within the country or specific region where the patient received care. The AI vendors themselves need to offer dedicated healthcare environments that are compliant with strict industry security standards, like HIRMEST or SUSI2 certifications. These are frameworks that validate their security and privacy controls. And critically, there must be signed Business Associate Agreements, or BAAs, in place. This is a legal contract that formalizes the shared responsibility for protecting patient data between the healthcare provider and the AI vendor.
That covers the technical and legal side. But what about the human element in all of this? You mentioned it earlier. Is there still always a human-in-the-loop safeguard, or is there a risk the AI just takes over decisions?
That human oversight is absolutely essential. It's a core safeguard. While AI can automate much of the repetitive processing work, the final review and clinical approval must always involve a qualified human professional. Clinical staff need to verify AI-generated referral summaries before they get sent out. They need to correct or maybe supplement automated prior authorization requests before submission, and they must provide medical oversight on any triage suggestions or facility matching recommendations made by the AI. The AI suggests, the human decides.
Non-negotiable oversight.
Non-negotiable. Additionally, health systems need robust model governance programs for the AI itself. This includes clear versioning and documentation of how the AI models work, regular audits for bias and fairness, making sure the AI isn't inadvertently treating certain patient groups differently. And even things like red teaming exercises, where security experts actively try to find vulnerabilities or trick the AI to ensure it's robust and safe.
It sounds like staying constantly updated on the evolving AI-specific health regulations is going to be vital. It's a fast-moving field, and ensuring patient trust remains paramount seems key. So, Bringing this all together then, it really feels like generative AI isn't just some small incremental improvement for healthcare referrals. You used the term step function change earlier.
I think that's accurate.
It seems to enable health systems to work smarter, faster, and much more collaboratively right across the board. It feels like it's fundamentally reshaping how care actually gets coordinated and delivered.
Precisely. This technology really empowers the people on the front lines, the care coordinators, the administrators, the clinicians themselves. It empowers them to focus on the high-value activities, the complex patient interactions, the critical thinking, by handling the repetitive, time-consuming elements of referral management automatically or semi-automatically.
Yeah.
And the outcome should be stronger clinical decision-making, significantly accelerated time to treatment for patients, and ultimately, a care model that feels much more truly patient-centric.
So, as we wrap up, here's a thought to leave you with. As AI becomes more and more deeply integrated into our health journey, not just for referrals, but potentially across many areas, what new ethical considerations might arise, specifically around that balance between the drive for efficiency, which AI offers, and the necessity of human oversight and judgment? And maybe how will navigating that balance shape the future of trust between patients, providers, and the technology itself in healthcare? Something to think about.